Sorry, a little bit late. Just trying to get everything set up. Just proving to be a little bit difficult for some reason today. I don't know why this is all being so difficult. Oh well. Let's just kind of go for it. All right. Hope you guys are doing well. So a couple things. Well, I don't know. I guess looks like we only have a couple people here right now. So I mean, I'm still gonna do stuff. I was gonna talk a little bit about some AP like logistics stuff, like not just content, but stuff about the AP test. But maybe I'll wait and try to see if more people are coming in. But no one's even said anything, so maybe no one's actually watching in general either. Or maybe my stream's busted. That's probably it. It wouldn't just be that no one wants to watch me do math. That would be absurd. Morning. There we go. Now we're cooking. What are you guys cooking for breakfast? Good morning. Okay. Let's just go ahead and start off then. And again, I have a couple AP kind of test announcement type things that I'm going to talk about, and Summit, like class-wise. But let's just do some math for now. Okay. So, you might notice for what I sent you is that this is packet 5. So we did we did some of the stuff from packets 1, 2, and 3, and then there's no packet 4. I sent you packet 5. There is a packet 4, but I was looking at packet 4, and I realized, hey, wait a minute, this is all stuff that technically isn't going to be on the AP test. Right? It was like polar equations and parametric stuff. So if you remember, polar and parametric equations are not going to be on the AP test. So I figured I'd go ahead and skip packet 4 and go to packet 5 and just kind of try to stick to more slightly relevant things. We don't vibe with it, and that's a capital V on vibe too. You guys know how it goes. Okay. Great. So let's go for it. Okay, number 1. Consider the differential equation dy dx equals 1 minus y. Let y equal f prime of x be the particular solution to this differential equation with the initial condition f of 1 equals 0. For the particular solution, for this particular solution, f of x is less than 1 for all values of x. Okay, so some good stuff to know. Let's look at part A. Part A first says use Euler's method starting at x equals 1. Okay, so first off, I have to remember what the hell Euler's method is, so I'm already freaking out. Starting at x1 with 2 steps of equal size. to approximate f of 0. Show the work that leads to your answer. All right. So for part A, first off, we just have to remember what in the world Euler's method is. Okay, and so Euler's method, that equation, this is a first. What? It's gotten so bad I'm gonna have to restart. Jeez. Someone buy Hayden a new computer, please. All right. This is now a charity stream. Okay. All donations, all Twitch Prime subs, that money is going towards purchasing Hayden a gold-plated Ethernet cable. That way the internet can flow flawlessly into his computer. Okay. Let's try to raise, I don't know, $6,000. That should be close to enough. We'll see. We'll look up some Ethernet cables later on. Okay. All right, so this is the formula for how we get from one step to the next for Euler's method. All right, so you might remember for this we made a table. So I'll go ahead and make a little table for myself for n, xn, yn. Okay, now I already know my starting point. Right, the initial condition f of 1 equals 0. So I know that if I plug in 1, I'll get 0. So that's my 0th step. That's just the beginning. Right, now it says to use 2 steps, so I know I'm going to have an n equals 1 and an n equals 2. And since the steps are of equal size, I need to decide what is my h equal? What is my step size? Well, remember here, we're starting at x equals 1. Okay, and we're trying to approximate what happens when x is 0. Okay, well, to get from 1 to 0, we just subtract 1. But then to get there in 2 steps, so my step size is -1/2. Okay, so that my first step will take me from 1 to 1/2. And then my second step will take me from 1/2 to 0. And now we just have to start plugging things in to our process. So we're using this in general. I want to know y1. Okay, so y1 equals y0 plus dy dx evaluated at x0, y0. Well, x0, y0 is just 1, 0. Times h, which we know is -1/2. Right, so let's actually plug in some values. y0 is 0. dy dx, if I plug in 1, 0, so here's dy dx. So remember, that's the x value, the y value that I plug in. Well, this equation doesn't even have a spot for an x value, so I really only need to plug in the y value. So 1 minus 0 is 1 times -1/2. So 0 plus, so that part doesn't matter. 1 times -1/2 is -1/2. So there's y1. All right, so we're almost there. Now, in order to figure out y2, so that would be, using my formula from up above here, that would be y1, so just 1 lower, plus dy dx evaluated at x1, y1, which x1, y1 is, I guess I'll go ahead and write 1/2, -1/2. times the step, which the step we know is negative 1/2. Okay, so let's just plug in now. Y1 is negative 1/2 plus dy dx. Remember, our formula for dy dx is just 1 minus y. So 1 minus the y value. So 1 minus negative 1/2. So that'd be 1 plus 1/2. So 3/2. I should have had RJ tell me that. Times the step, just negative 1/2. So negative 1/2 minus 3 times 1 is 1, or sorry, 3 times 1 is 3, 2 times 2 is 4. So let me combine these together by getting a common denominator. So instead of negative 1/2, let me write that as negative 2 over 4 minus 3 over 4 equals negative, not halves. What am I doing? Negative 2 minus 3 is negative 5, and we keep the denominators the same. So we get negative 5/4. So f of 2, right? That's what we're, or no, sorry, not f of 2, f of 0. It was 2 steps, but we're trying to approximate f of 0. So f of 0 is approximately negative 5/4. Right, so that's just using Euler's method. It's probably good to see again. I know some of you still need to, use that to pass a PFA. So it's really just, for Euler's method, you got to know this, just kind of off the top of your head. And then it's just, kind of filling out the table. There's n's on the left side. It's just however many steps. The problem will always tell you how many steps. So ours told us 2 steps. So we start at 0 always, but then 1, 2, the 2 steps. And then we were trying to get from, we started at 1 or trying to approximate 0. So that's why we went down by 1/2 each time. And that's how we decided h is negative 1/2. Then we just go through and approximate. Okay, part B. Find the limits as x approaches 1 of f of x over x cubed minus 1. Interesting. Okay. Show the work that leads to your answer. All right. Great. So the limit as x approaches 1 of f of x over x cubed minus 1. Now remember, if we're trying to evaluate a limit, the first thing we always try to do is just look at what the limit is approaching and try to see if you can just plug that in. Right, so let's see what would happen if we did that. So that would be f of 1 over 1 cubed minus 1. 1 cubed minus 1 is 0, and f of 1, we know from our initial condition, f of 1 is 0 as well. All right, so I end up with 0 over 0, which is an indeterminate form. And we know if we get 0 over 0 or infinity over infinity, then we should use L'Hopital's rule. Okay, so let's that's not an S. Exclamation point, because we're excited about it. So let's take the derivative. limit as x approaches 1, f of x, so the derivative of x, or sorry, the derivative of f, we'll just call it f prime. The derivative of the denominator, 3x squared. Okay, so now if we try to plug this in, now let's try to plug in 1, see what we get. So f prime of 1, 3, 1 squared. So the denominator would be 1 squared is 1, 1 times 3 is 3. Now f prime of 1, right, that's the same thing as saying or wait a minute, sorry, hold on. Let me go back to my equation. What was my equation? Oh, hold on, I lost track of it on my screen. So where'd it go? That's the wrong thing. What am I doing? Oh, okay. Sorry. My fault. What is this? Cancel. Oh, that's why. Oh, I see. Okay. I had 2 different Smart Notebook files open that were the same thing, and so I was confused. Okay. Let's go back. What was I saying? For f prime of 1, yeah, so dy dx whenever x equals 1. Now, dy dx is 1 minus y. Well, so you might be a little confused on then, well, x equals 1, x doesn't equal, I don't know the value of y. What do I plug in for y? But we know from the start that, let me erase some of this. We know from the start that if x is 1, that means that y is 0. Okay, so now whenever I do this, by saying x equals 1, that's also the same spot that y is 0. So instead of 1 minus y, I have 1 minus 0, which is just 1. So that limit is 1/3. Okay, so it's just connecting all of our pieces together that we have from our initial conditions. Part C. Find the particular solution to y equals f of x to the differential equation dy dx equals 1 minus y. So the same equation as before and the same initial condition as before. We're trying to find the particular solution. So let me just write down that stuff again. So dy dx equals 1 minus y. F of 1 equals 0. And we're trying to find the particular solution. So when we're trying to solve a differential equation, right? So my goal is that at the end I have an equation that's just y equals, whatever. It's not, has no derivative in it. Doesn't have a dy dx, right? So what we called these types of equations that we could solve was, or the only type that we learned how to solve is called separable equations. So we want to separate the things onto the different sides. So on one side, I want to have just y and dy stuff. On the other side, I want to have just x and dx stuff. Okay. Now, a big mistake that you can do here is if you try to, here's sometimes what I see people do. So this is wrong, what I'm about to write. Right, so people multiply both sides by dx, so it disappears on the left and then comes on the right, and then the minus y, they think, okay, add the y to both sides, you know, or they write it like this, either way, of y plus dy. Okay, but this is not helpful to us. All right, even though you're right that it is just y and dy on the left side, it's this plus sign in the middle that screws things up. Right, we have never done anything that is like plus dy. What is that, you know, what can we do with this? If we want to integrate something, which is what we want to do, then we just have to have like times dy, right? Not plus dy, not minus dy, right? Just like a times dy. So I don't want to do that. Don't add y to both sides. Okay, but I can still do something. So here's what I'm going to do is we can first multiply both sides by dx. That's fine. Right, but I don't want this 1 minus y to be with the dx, and it's, you know, grouped together in those parentheses. So instead, I will divide 1 minus y and divide my 1 minus y. And then on the right side, I just have dx. From here, now that the equation is separated, we need to integrate both sides. So integrating that right side is easy. The derivative of dx, right, is just x, right? That's like saying the antiderivative. The antiderivative of 1 is just x, because the derivative of x is 1, right? And we'll say plus c, right, plus some constant of integration. On the left side, 1 over 1 minus y. So this would be natural log of 1 minus y. But it would have a negative in front. So what this is on the left side is sort of like a fast-forwarded u substitution. Right? If I did u equals 1 minus y, du dy equals negative 1. So negative du equals dy. So integral of 1 over u, negative du. Antiderivative of 1 over u is just natural log of u. So negative natural log of u, but we substitute back in our 1 minus y. Okay. This is like the super expanded version. This is the fast-forwarded version. If you still need to write out all of those steps on the right side like that, you know, that's fine. But it's kind of the equivalent of if I had an equation that was 5x plus 3 equals 8. You know, you could actually write out like, okay, minus 3 on both sides, minus 3. So 5x equals 5. All right. Divide by 5 on both sides. Divide by 5. Okay. X equals 1. Right, that blue stuff, you can see it. Right, if I'm looking at this stuff, that blue stuff, like, you guys would never write that. At least I don't think I ever see you guys writing stuff like that. Because you can just go from here to here realizing that you subtracted 3 on both sides, or go from here to here realizing that you divided 5 on both sides without writing it explicitly. Okay, so that's the same thing we're talking about here. Is, it'd be great if save yourself a lot of time in writing if you could just go from here to here recognizing what would happen. Okay, kind of going through the U substitution part just in your head. Okay, remember we would get a plus C on both sides when we integrate, but we can just kind of condense it all together. Let's say we added or brought the left side constant over to the right side, and we can just use this all-encompassing plus C. Okay. So let's figure out what C should be now. Because we know f of 1 is 0. So let's use our initial conditions to then solve. So f of 1 is 0. So if I plug in 1, if I plug in 1 for the x value, I should get 0 for the y value. So 1 minus 0. Great, that's just natural log of 1. Equals 1 plus c. If x is 1, y is 0. Okay, let's solve for c. Natural log of 1 is 0, so negative 0 is 0. So I get 0 equals 1 plus c, aka c equals negative 1. Okay, so now let me take this, and instead of having c, I'll plug in the c that I found. So negative natural log of 1 minus y equals x minus 1. I have this negative out in front, so I'll go ahead and divide everything by a negative. So that would just turn this positive. Negative x and plus 1. And so I'll rearrange it so it's 1 minus x instead. Okay, how do we get rid of natural log? Then we use e, right? We take everything to an exponential. So that would get rid of, well, wait, hold on. Let me go back to my initial conditions and check something real quick. Okay. Okay, so we're going to take everything to the e, so e to the power of 1 minus x. And then e to the natural log would just get rid of the natural log part. Just leaving me with the 1 minus y. And now I can just subtract, right, or rearrange. So I'll add y to both sides and then subtract this over to the left. So 1 minus e to the 1 minus x equals y. All right, or I guess more specifically, equals f of x. This is the particular solution. Right, particular meaning we use the initial condition to figure out what c should be. If we had just stopped here, right, where we don't know what c is, this would be, well, I guess we would still have to go through and solve for y, but this would be how we would get the general solution if we don't know c. But we knew the initial condition, f of 1 equals 0, so we were able to use that to get the particular solution. So that's part C. Does anyone know if Hayden's alive? Is he back? Number 2, the rate at which a baby bird, Aw. Gains weight is proportional to the difference between its adult weight. I don't even know that. Only on the outside, right, Hayden? And its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. We have this model. Okay, of the rate, dB/dt. Let y equals b of t be the solution to a differential equation with the... So again, we already told this, but the initial condition, if we plug in 0, we get 20. I'm going to fat shame a bird. Okay. So, where are we at here? Let's try to... Okay, this is a new rule for the stream. Alright, you're not allowed to do this. If anybody fat shames a bird, moderators, please time them out. Thank you. Ugh. Hey, that was pretty good, right? Writing that, no fat shaming birds, please. Not bad. I am a fencing coach. If you're here in the evenings, it's my fencing stream. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Okay. So for part A, I don't want to scroll. Let's just... So gaining weight faster, again, B represents the weight. So dB/dt must be the rate of the weight, right? So is the rate increasing? Is it gaining weight? Or is the rate decreasing? Is it losing weight? And how fast specifically? So let's just take this equation and plug in 40 or plug in 70. Let's compare. So dB/dt whenever B is 40, I already forgot what the equation was. 1/5, 100 minus 40. 100 minus 40 is 60. 60 times 1/5 would be 12. 12, what is this, grams? Grams per day. Since 12 is positive, then it tells me that this bird is gaining 12 grams per day whenever its weight is 40. But let's see how that is whenever its weight is 70 grams. So 1/5, 100 minus 70. 100 minus 70 would be 30. 30 times 1/5 would be 6. Okay, so again, a positive 6, so it's gaining 6 grams per day. But we can clearly see that this 12 is larger than 6. So what does that mean? The bird is, how did it word it on the question? Is the bird gaining weight faster? Okay, the bird is gaining weight faster when its weight is 70 grams. How do we know that? Okay, again, I think it asks for justify or give a reason. Yeah, explain your reasoning. So since, let's just use our math that we did. Okay, since the rate whenever the weight is 40 is greater than the rate whenever the rate is 70. Right, it's gaining more whenever it's less weight. Okay, which makes intuitive sense. You know, when you're growing up, whenever you're younger, like a baby or a toddler, you know, you're gaining more weight faster than if compared to, you know, when you're in high school and you're not growing as much. Right, that idea should make sense. Don't get banned for all caps again. Oops. Yeah, you're right. Sorry. 40. Thank you. Yeah, should be 40 grams, not 70. Wouldn't it be when its weight is 40? Yeah. Screwed up. Sorry. I'm sorry. Okay, so that's part A. I think I'm 20 seconds behind. Maybe. That's fine. Oh God, good luck refreshing. All right, part B. Find the second derivative, right? D squared B over dt squared. In terms of B, use the second derivative to explain why the graph of B cannot resemble the following graph. Okay, so it's giving me a graph and it's saying this is not what the graph of our equation should look like. And it's asking us, why is that? Explain why that is. Okay, so let's find. Actually, this is going to bring up an interesting question, because I did this and I got the same final answer, and then I looked at what they did in their answer key, and it's again same final answer, but they did something different, and I don't understand what they did, or maybe I'm just missing something. So you guys can decipher that for me, since you're smarter. All right, so here's dB dt. And we clearly have our masters in math. That is true. I totally agree. Actually, I think I know what they did, but let me try to do it the way they did it. Okay. So we need to take the second derivative, right? So our goal, d squared b over dt squared. So here's kind of the confusing part. This is deriving with respect to t, but over here we have a b. Okay, so this is different than just doing normal derivatives. Right, so let's let me come up with a different example. Let's say d capital A dt is 2a. All right, so this is just something totally separate that I'm making up. I think the common mistake would people say, oh, take the derivative. The derivative of 2a is just 2, right? That's not true. That would only be if this were an t. Right? That bottom variable, the d whatever over d, that denominator variable, that's what we can just use regular derivative rules with. But now, right, we have this variable matches with, the top variable. Right? So if you remember back from AB, what we had to do was implicit differentiation. So we can say, all right, the derivative of 2a is 2, but then we have to chain rule and add on this dA dt on the end of it. Okay, so same thing over here. Actually, first I'm going to distribute this just to make it easier on myself. 1/5 times 100 is 20. Right, minus 1/5 b. Okay, so the derivative of this, derivative of 20 is 0. Great. The derivative of negative 1/5 b, so that's negative 1/5, but this is b. This is not taking the derivative of t. So we'd have to use chain rule dB dt. Well, dB dt is this stupid equation again, right? So 1/5 100 minus capital B. Okay, so are you sticking with me here? What I'm talking about with the implicit differentiation, right? We did things like this where we had like let's say, you know, y equals 3x plus 5y squared. So if we wanted, so I got y's on both sides, right? So if I want to take the derivative dy dx, so I'm taking the derivative with respect to x, so for the x stuff I can do it normally. Derivative of 3x is 3. But when I come to y stuff, so I can do my rules. So like here I would just do chain rule. So 5y squared, that derivative is 10y. But then I would need to chain rule and put dy dx on the end. Okay, that's exactly what we're talking about here with this equation. Negative 1/5 b, yeah, that derivative is negative 1/5, but then chain rule dB dt. All right, which equals this. So let me simplify it. Negative 1/5 times 1/5, negative 1/25. 100 minus b. All right. So when I look and I say, okay, this is d squared b dt squared, right? The second derivative. So I want to know if I were to graph this, why is it not the same as this graph? And to figure that out, let's think about second derivatives. What do second, or there's a lot of things it can tell us, but what do second derivatives tell us? What's some of the things that jump out at us? Second derivatives we can use to find points of inflection. Second derivatives tell us concavity. And so that's what I'm gonna think about. This second derivative, so remember my values of b that we're plugging in, this is between b, or where is it? Where does it say? Oh yeah, okay, we're starting at time equals 0. Starting weight 20 grams. And this graph is, we don't really know, we know the values on the y-axis. Oh, but actually we know this graph is going from 0, and then its highest value that it's going to hit is 100. Right, the weight. The highest weight that we can see this graph hitting is 100. Okay, so actually it won't ever actually hit 100. So whatever we plug in for b is going to be something between, you know, 0 and 100, and actually 20 and 100 because it starts at 20. So that means this number, 100 minus b, will always be a positive number. But then we have this times negative 1/25. So this always a positive times always a negative. So this overall will be always negative. And if a second derivative is negative, and more specifically always negative, then we should be able to say it's always concave down. Right, but let's go back to our graph. This graph is definitely not always concave down. It's concave down for like this part of the graph, but this first piece is clearly concave up, right? And then it hits an inflection point and then starts becoming concave down, this pink part. But the equation that we found, or the equation that we're using, because I can see that second derivative will always end up being negative, then that graph of this, whatever it looks like, should always be concave down. All right, so we're going to have to explain why the graph. Okay. So let's just basically write out what we just wrote kind of shorter. So the graph of this second derivative will always be concave down. But the graph given to us has parts that are concave up, or portion, whatever. Right, so it can't be that that's actually the graph for the second derivative. It just doesn't fit. Okay, let's go to part C. Use separation of variables. Okay, well that's nice. It's telling me specifically what to use. The particular solution. Okay, so we're trying to find a particular solution again, and we have our starting amount. Okay, so let me just copy this down again. dB dt equals 1/5. Okay, times 100 minus b. So again, I want to separate. I want to put the b stuff with the dB. I want to put the anything, if there were t, I would want to put the t stuff with the dt. All right. But remember, when you're doing separation of variables, you should never be like adding and subtracting to either side. All right, it should be explicitly things like multiplying, dividing. Actually, it should pretty much strictly be multiplying or dividing to separate two sides. Okay. So let's divide both sides by 100 minus b. And let's multiply dt on both sides so that I end up with this. I guess I'll go ahead and write this. Go ahead and write it like this to keep it consistent. All right, so everything's nicely separated. If you wanted to move the 5 over to the left side, if you wanted to multiply both sides by 5, you could. I'm not going to, but you can. All right, so now we would want to integrate both sides. So indefinite integral for both sides. At right side, it's easy, right? Antiderivative of 1/5 is just 1/5 t, since we're integrating, right, with respect to t, dt. And on the left side, I'll go ahead and put my plus c over here as well. On the left side, again, this is basically like we talked about before. You could go through and do the full u substitution, or you can recognize this would be a natural log antiderivative. So natural log of 100 minus b. But double check yourself. So if I took the derivative of this, so I'd have 1 over 100 minus b, but then chain rule, I'd have to multiply by the derivative of the inside, which would give me a derivative of negative 1. So actually, I would need a negative out here. Right. Or you can do the full u substitution. U equals 100 minus b. du equals negative db. Right. Negative du equals db. Okay, so natural log negative 1 over u du, negative natural log u, negative natural log 100 minus b. All right, you can go through those steps, but it's better if you can just recognize and get it done. But, you know, also not bad to be certain. Okay. Notice again on the left side, I did not put a plus c because I'm just assuming I'm just going to bring both my plus c's over to the right side. And it'll just kind of, they'll combine together to create a new c, but it doesn't matter because it's still just some constant. So we can do that. Right. Let's use our initial value. So we know b of 0 is 20, right? I think that was the initial value. Yeah, b of 0 is 20. So let's use that to solve. So if t is 0, then b will be 20. So negative natural log 100 minus 20, 80. 1/5 times 0, so that's 0 plus c. Okay, great. So c is negative natural log of 80. That's not the prettiest constant to have. Like our last constant was negative 1, I think. So that was nice, but oh well. All right, so we know c, so let's use this again, but now we know what c is. So negative natural log 100 minus b equals 1/5 t plus c, but plus c we just decided is minus natural log of 80. I don't like this negative, so I'm gonna divide every term by a negative on both sides, or multiply every term by a negative on both sides. So that would change it to natural log 100 minus b equals, this term would become negative, this term would become positive, so I'm just going to switch their positions. Natural log of 80 minus 1/5 t. And how do I get rid of this? I'm trying to solve for b, so how do I get rid of this natural log? Use e, right? Make everything an exponential. So e to the power of this whole left side, so that would cancel the natural log, just leaving me with 100 minus b. And then e to the natural log of 80 minus 1/5 t. Thanks to exponent rules, this subtraction in the exponent tells me I can split this up. E to the natural log of 80 times e to the negative 1/5 t. I have e to the power of natural log, so those will cancel each other out. So 100 minus b equals 80 times e to the negative 1/5 t. Add b to both sides, subtract this whole thing from both sides, so I end up with 100 minus 80 e to the negative 1/5 t equals b. Boom. Okay, so again, I wanted to talk about a few AP things. I know we're kind of out of the official time, so I'm sorry about that. I'll include this in the YouTube video if you have to go do something else right now, but I would stay here if you can so you can ask questions. So first things, just for shoot, I already lost it. Come on. Just for our class, okay, I'll try to make this bigger. Okay, so I don't know if you noticed, I reorganized our focus areas. So you can see now we only have 5 power focus areas and 5 additionals. Okay, I moved a bunch of things over to challenge just because part of those were things that we just aren't going to be able to cover. Okay, because of they're not going to be on the AP tests, and I'm not going to force you to do those things because we're not in class learning them. Okay, all of these power focus areas are good to go. Ending with sequences and series. Okay, that last one that we had talked about. And so for additionals, there's really not a lot of like new additionals. So one of the additionals is AP test prep. 2 of them were ones from last year. So really it was just like vector valued functions, which is also something that's not going to be on the AP test, but I'm still leaving it in here for additionals. And more convergence tests, which this is the one that I'm going to convert, or I'm in the process of converting to Taylor polynomial stuff. I'm trying to get that done as soon as I can. AP test prep, additional. Again, so first objective, AB, is all this stuff. There's also a link. Remember, this is the AP College Board. I told you they have that YouTube channel because they do live streams every day. This takes you to the playlist for AB. Same thing with BC. Okay, takes you to BC. Playlist of videos. Those are excellent resources. Okay, excellent resources to use because right, all of these playlists of things. Well, wait, that's the same one. Hold on. Maybe it didn't link like I wanted it to. I'll relink that. But again, so if you look at this full playlist, right now there's 26 videos in here for BC and the same amount for AB. All right, and especially if you look through, now maybe you don't want to watch every single one of these. Like, again, parametric, not going to be on the AP test. So like these first 3 videos, forget about them. Okay, but things like series tests, but specifically be on the lookout for things that they're titled like FRQ, right? Like this video is titled Convergence and Taylor Polynomials, which is going to be on the AP test and we've talked about. But review and FRQ practice. Right, again, what I've been telling you guys need as much FRQ practice as possible. Right? Not just, short multiple choice questions, but legit FRQ practice. So there's a review and FRQ practice. Here's another one. Integration techniques. That's like from our first PFA this year. Integration by parts, partial fraction decomposition, stuff like that. Things that were kind of hard. Review and FRQ practice. Right? So you're not only reviewing the material, but you're also learning it in an FRQ setting, which is super important because that's the only type of question you have this year is FRQ. Right? Same thing. Euler's method, review and FRQ practice. Logistic growth, review and FRQ practice. Arc length, review and FRQ practice, all right? I think you get my picture, right? These don't say that specifically. I mean, is it still good to, I guess these are ones that actually haven't happened yet. But in a couple days, there's planned AP FRQ problem types, graphical STEM, so like graph-based FRQ questions. Again, FRQ. So especially if you're not going to go through and look at specific topics, I'd highly recommend, well, you should, first of all, but at least look through and go through those FRQ questions because you guys absolutely need that FRQ practice and the familiarity with how things are worded or those types of questions, etc. Right? Same thing goes in the AB playlist. If you go to the AB playlist, there's days that are just like that. In the title it says like FRQ practice or something like that. Okay, do it. There's also all of these FRQ scoring guides for BC, for AB. There's full practice exams. Those flashcards I was talking about. Resources. This is that sheet that I was talking about, stuff you have to know cold. Right? It's in Objective 3 of that AFA for the AP test. Okay, so I'm going to say this every single day. I'm going to act like you guys aren't studying at all. I don't know if you are or not, but I'm going to act like every day that you're not because, again, I'm trying to stress to you. I know I'm not the one taking the AP test, but I too am stressed because everything's so crazy and I worry about you guys as well, and I just want you to be as ready as possible. Plus, it's just a hard test, right? Regardless of if it was just the FRQs or the normal test. Okay, so you should be doing stuff every day to get ready for this exam. Okay, I also have an update. I still have seen, I scoured the AP website constantly, and I never saw, and I still don't see, anything that specifically says that there is no AB subscore this year. However, as I've looked in as I've talked to other calculus teachers, and as I've looked in like group forums and like groups that are just AP Calc teachers, right? They're saying that there is no AB subscore. I reached out to administration, and the only answer I've gotten was from a teacher at Park Hill South that said, yeah, there's not going to be an AB subscore. Right? So even though I don't see it on the website, I still don't see it on the website anywhere. Maybe I'm just an idiot and can't read. But I would say, I guess the expectation now is that there will not be an AB subscore this year if you're taking the BC test. Okay, so I think what that means, though, is if you want to switch from BC to AB and just take the AB test, like if you were planning on not really caring about if you specifically get the BC credit, but you just want the AB credit, okay, then you can switch. I believe, I believe what I'm told, at least for South definitely. I think for regular Park Hill as well. I need to confirm, but I think you just inform me if you want to switch from BC to AB. I don't know that I'm saying I recommend it, I don't, just because I don't have any clue what it'll be like. If you by any chance, you're only juniors, if you by any chance know what college you want to go to, you could potentially reach out to them and ask them, like, hey, I'm just trying to get Calc 1 credit, so should I just switch to just take the AB exam? Or, hey, if I'm going to take the BC exam, and if I get a sufficient score, will that be good enough to then say that I got the AB credit even though I didn't take the AB exam? Like, I don't know. It sucks. I hate it. It's not a... It's not a perfect situation at all. But if that's something you want to do, please inform me as soon as possible. Okay, I know I just kind of sprung this on you, but it's because I still have not received any official information ever about this. It's just from hearing it from other people and then trying to confirm. Oh, actually. Okay, apparently there is a deadline for that. I don't know. I'm still going to try to figure out more in the next day about the actual process of doing that, and if there is or was a deadline or what that looks like. But if you can, in the next day or so, again, I know it's super fast, but if you're thinking that that's what you want to do, let me know so that I can then try to talk to whoever I need to talk to. I'm trying to like read through my emails right now because I'm still getting information about this after I reached out because no one addressed me. But I'm seeing if there is something about a deadline, potentially maybe even has already passed, but we can figure that out, and we can talk to whoever we need to talk to and talk to College Board if that's still something you want to do. I'm sorry, but again, like I said, I've been looking for this constantly to try to see if there's still going to be a sub score or not, and it's nothing that I see on the official website. There's nothing that the administration from either high school has communicated to me about that. So I'm sorry if so, but just let me know if that's something you want to do, that you just want to not, if you want to switch from BC to AB, then we can try to figure that out. I can't guarantee it, but try to let me know as soon as you can if that's something you want to do, and we'll work through it. Ideally, like, I know that's super fast, but ideally like in the next day. That would be awesome. Okay. So, yeah, so just, I guess overall, I reorganized the PFAs and the AFAs. That should look a little better for you. Be studying still use these videos, because again, these videos are specifically put out by the College Board, right? And they're the ones that make the tests, so it must be that this stuff is helpful and important and good to use, right? And otherwise, I will talk to you tomorrow. I'll still be trying to talk to as many people as I can about figuring out whatever's things going on, but the information I'm receiving is that there will not be an AB subscore. So if you want to try again, no guarantee, but if you want to try to switch from the BC test to the AB test, let me know as soon as humanly possible. Okay? All right. I know I went like 20 minutes over, but, well, I guess no. We're still fine. Any immediate questions for me here? I just talked a long time. No? Okay. I will keep frantically working. And would you say it's likely or a possibility we won't get credit without the sub score? I have no idea. What I would like to say is that if you, so let's say maybe the college that you go to, in order to accept BC credit, so that would be credit all the way up through Calculus 2, right? That maybe the college normally says, like, if you get a 4 or a 5 on your BC test, then you get the credit for Calc 1 and Calc 2, right? But and you would get, your AB subscore would account for that too. But maybe if you're only getting a BC score, I would really love to think that colleges would just say, all right, well, we usually require 4 or a 5 to get BC credit, but let's say if you just got a 3, then we'll give you AB credit. But I don't have anything to back that up. And I'm sure that every college is going to tackle it differently and do a different process. So I don't know. I really don't know. Some colleges might still say, even if you only took the BC test, as long as you got this good enough score, like a 3, then we'll, maybe we won't maybe with a score of a 3 on the BC test, we won't give you BC credit, but we'll give you AB credit. I don't know. That would be my hope, but I can't. I have nothing to back that up. Can we take both? That's what I've seen a lot of people wanting that. I've seen no information about that actually happening. That would also be the other ideal, if you could just take both. There's been no information saying that you can do that yet, but there's also been no information that I've seen. Again, I only learned about the subscore thing from a freaking Facebook group. I saw people talking about it, and I was like, I don't even know where this came from, but you guys can go look at the AP website. Maybe it says it, and I just don't know where to look, but I've looked at that page like every day. Contacting them is probably the best starting point. Probably. Technically, not all colleges have agreed to give credit for the modified test at all. That's also true. That is also true. There's no way of saying that every college in the United States will actually accept this modified test still as credit. I think many will, because otherwise I don't think AP would be holding the test. Maybe that's delusional on my part, but we're just in such uncharted territory with everything. But yeah, so contacting them, that's probably your best bet. But let me know anyways. So first of all, also let me know just if you don't want to take the test at all. I know I said that earlier, or a couple weeks ago, but if you're not wanting to take it at all anymore, just because of the craziness and uncertainty, okay, let me know about that, because I also need to tell the administrators about that soon. But if you're wanting to switch to AB instead of BC test, then for one, let me know that. And then two, you could also try to contact them directly so that you don't have to worry about you telling me and then I tell administration and administration tells whoever, and then it eventually works the way up the line. You could also try that. But please still do contact me because there's still stuff that we would have to do on our side. I don't know. It's just such... I don't know. I'm defeated. And again, I know I'm not taking the test, but I am super stressed about it as well. Trust me. I wish I had better answers for you guys. I wish there weren't so many variables. I don't know. Okay. So yeah, all that stuff I said, again, try to let me know ASAP if either you're not wanting to take the test anymore or if you're wanting to try, emphasis on try, to switch from BC to AB. Then we can work on that. But let me know as soon as you can. Otherwise, I will see you guys back tomorrow. Okay? Good luck. Hang in there. We'll make it, I think. But email me with whatever you have. Questions, concerns, information. All right. See you guys.